All right. Hello everyone. Um yeah, welcome back. Today is day 51 and I'd like to um you know make this session a bit special. Um so there was something I actually planned to do lead code questions today, but then I just realized I'd already done 51 days, right? And, Lead Code just gave me this badge here, which is really awesome. And yeah, I'm happy. I'm happy to have achieved, half of the days I set to learn lead coding for. And I'm really happy for this achievement. And yeah, so it's been really good, and I just like to take this day to you know how do I put it, revise or go over everything I've done so far, right? So um there is I've solved quite a number of questions, but the best thing to do when learning is to revise and repeat 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 stuff, right? Repeat um the questions you solved, repeat everything. And I've honestly not been doing that entirely. I'll say to like 50% of the questions I've solved so far I have repeated, but that is not good enough, right? Let me just increase this. The best thing to do is to repeat every questions you solved, to be able to retain them properly, and help your memory to retain those solutions, right? So it's been a fascinating journey so far, and I enjoyed every moment spent here on YouTube solving these questions. So I still have 50 more days to go, right? This is just um a learning series, right? This showing you guys everything I've been learning so far, and every questions I solve, everything I do daily, then I share them here on this channel. So it's been good, it's been awesome, and I I totally enjoyed um I totally enjoyed everything here. So let's you know go over a few questions. I would have selected some questions, but again, today I was just so busy at work, and I've not been able to go through my lead code list anymore. I think the best thing to do now going forward is to um do these questions during um, the early hours of morning, and then later during the evening I can just revise, set up my questions, and then stream, because I go to work too, so there is usually um, a lot going on during the day, and I get carried away. So um, let's see what we can do. First of all, I will start. So I have some problem set here. Let's see. So there are a lot of problems here, but I'll just go over. So here is a two pointer question, right? I mean the two pointer algorithm, and there are a lot of questions under two pointers, but I've solved not many, but like a few two pointers questions. But I would like to go over those questions again and try to solve them this time around. So let's start with the easy ones. I will sort this. So this is easy. So it's going to go from easy to the most difficult one. I can choose, three 3, 4, 5 questions and use these as my so let me take, instead of doing this, okay, you can see I still have the badge here, which is really nice, right? Okay, that's cool, that's awesome. So I'm just going to close everything, right? I'm going to close everything. I think I'll have the badge on my profile. I'm not sure why Let's Code hasn't. Is there any badge? No badge. No. Okay. Okay. Yes. So the badge is there. All right. That's not what we are here. That's not what we are here for. Let's see some question. The arithmetic triplet. Now I don't remember what this question is. Right. I don't really remember what it is. So, but I'll just open it and see what it is. So, okay, I can see there is this. You are given a zero index strictly increasing integer norms and a positive integer difference, right? A triplet A, J, K is an arithmetic triplet if the following conditions are met. So if I is less than J, J is less than K, right? Oh, I remember this question. I remember this question now, and I remember I was a bit frustrated with this question. Even my solution here was not the best. I think I made a cup. Okay, that was the only submission I made. Now you can see it worked, but this is in terms of time complexity, this is not good at all, right? This is going to be O of n squared and O of n cubed, right? So well, either way, right, when you look at this question, let's see how we can solve this. It says it's a 2-pointer question, which I am beginning to question why it is a 2-pointer question. So the array is sorted. Good. Okay. Now we want to find diff, right? The difference. A positive integer, which is also an input to our function. So there's a diff here, and then we are given a list or an array in which we want to find I, J, and K. Now the conditions are such that I is going to be less than J, J is going to be less than K, and then the number at J should be less than, the difference between the number at J should be less than the difference between the number at I, right? And then, sorry, the difference between the number at J and number at I should be equal to the difference, and the number at K minus number at J should be equal to the difference as well. I promise you, after solving this question, right, this way, which are obviously new, the conditions are actually respected in this case. You can see I started from here, J is 1 more than I, and K is 1 more than J, 1 less than, sorry, 1 more than J, 1 more than I, right? And 2 more than I. So, this works, right? This works, but it was just my brute force solution that I came up with, and it worked. I did not really implement any 2-pointer algorithm here to solve this question. So, but let's take a look at the hint. Are all the constraints small enough for a brute force solution? Yes, the constraints work for a brute force solution. You can see the constraint says the length of our array will be superior or equal to 3 or less or equal to 200, right? Which means the item in the array is going to be this much. Now, the number at I is either going to be 3. So this, num2 is strictly increasing, which means it's a sorted array. So, and the second hint says what? We can use 3 loop, we can use 3 loop, iterating through the array, go through every possible triplet, but be sure no duplicates. Be sure to not count duplicates. Sorry, be sure to not count duplicates. This question, well, it works for a brute force solution, but I've never taken my time to find out about how I could optimize this, right? Which is not really good. So those are one of the things I'll point out in this session. Let's take a look at some two-pointer solution by some of the people here. Now my submission was 32%. I mean, it's okay. So let's see a two-pointer solution, which is also a Python. Okay, so I'll take this one here, which is the first one, and let's take a look. Hopefully there are some detailed explanation for this. So here is what use. Oh, you see. Oh, use binary search to find out if norms at I plus the diff, right, and norms at, you see, this is really not, it's actually out of the scope of the question, right? In the sense that someone who has not learned about binary search would not be able to understand the solution, right? This is good. I mean, I don't know how effective this solution is. The time complexity is so let's read this. So use binary search to find out if norms at I plus the difference and norms at I plus 2 times the difference is present in the array. If not, or not, right? If both are present in array, increment the count by 1. If any of them is not present in the array, continue. I'm not sure if I understand this, but let's see. So there's a binary search here. Binary search is simply dividing the array into halves until we find our target, right? So I mean, we use the norms array, which is our input, and then we choose a value, supposedly the value we are looking at, right? We are looking for in this norm here. So in this norms array, so let's see, norms, this is going to be the length, count is going to be 1, and so self binary search, so we have x is equal to binary search, this will take the first two, I mean from 2 downwards. I'm not sure if I understand this solution. Honestly, I don't. There's no time to waste time. I mean, if I were, outside this stream, I would have spent my time trying to understand the question, but I mean the solution. But then again, it doesn't really matter at this point. So, I mean, yes. So let's see this. Use the same approach as a two-sum array. Yeah, approach 2 times, right? So the first time we store norms at R, the biggest number in our pair, onto our dictionary. This is important for finding the third number, yes. So the second time running the loop, we check if the norms at I, aka our middle, or our triple in the dictionary. Let me see what it is. So we have a result which is going to increment, I guess, every time, and then so arithmetic triplets, right? So number at this point, so we'll store every item here to keep the unique strings we've seen, I mean unique numbers we've seen so far, right? Oh, somebody is in the stream. Hey, hello. Hi, 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 hi. Okay, so let me continue. So while R is less than the length of the norms, I'm not sure. Okay, so left and right. I mean, this sure looks simple, but you know what? Let's first of all, I mean, the brute force solution works, right? But I'm just looking for a way to optimize this, and optimizing solutions, requires a lot of attention to detail, right? And I've not been able to come up with that myself, but so many of us, after thinking about best approaches to the problem, at the end we just apply the brute force approach. Okay. So you know what? Let's take this array, right? I'll use this, and so I'll copy everything here. These are our inputs, right? Now we'll then apply some form of mathematic logic, not complex math. At least I'm not a, a no, I don't really know about complex math, but this is just basic mathematics that we'll do here, right? So let's say we take this, right? I'll just delete this, and let's represent our array. So I'll put our array here. If I spend another more 2 minutes on this question, without arriving at the solution, we'll move on to the next thing. And yeah, so not to waste time, but I'm just recapping everything I've done so far. So yeah, we want triplets, right? So we're 2 pointers, number of arithmetic triplets, right? Now the arithmetic triplets are indexes in the array. So there are indexes in the array, and our array is such that there is I'll bring this down. So this is going to be 0. Why is this like 0, 1, 2, 3, 4, 5, right? We have 6 items in our array so far. Now we want to find the arithmetic triplet such that so I is less than j is less than k, right? I is less than j is less than k. And then we also want the difference, number at j minus number at I should be equal to the difference, which is our second input. So nums at j minus nums at I should be equal to the diff, like this. And then we'll have nums at k. I don't know if it's k, but let's see. Yeah, nums at k minus nums at j should be equal to the difference as well. Nums at j should also be equal to the difference, right? Now so with this equation, right, we can substitute the values of certain items here, right? Let's say, for instance, by looking at the array, right, we know 0 is less than 1, right? 1 is also less than 2, right? So incrementally, this will always work like that, right? So we know each item is less than the other one in the array. That is good. And then we want, so let me put this way. So we know 0 is less than 1 is less than 2, right? Which is this first 3 items in the array. These first 3 items in the array. Now, how do we check if these 3 items are if they are arithmetic triplets, right? So this condition has to be also, these two conditions here I mean, we've already validated this condition, which is 0 is less than 1, 0, 1 is less than 2, right? These first three items. That works for, you know, the first three item, right, which is from here towards to this point. Now, the second, so this is checked off, right? We need to find out if these three items also, you know, also works for this condition. So we know norms at j. This is our j here. So the first one, right, minus, which is 1, minus norms at I, which is 0, right? Norms at j is 1 minus norms at I should be equal to the difference, which is 3. Now, this condition doesn't work, right? But another thing to note is, are we selecting these items arbitrarily, or we are just going in a specific order, right, from smaller number towards bigger ones? I don't know, honestly. I don't know, but I'm sure it is always going to be like that, where we are not going to choose items randomly. We are just going to choose item in a specific order, right? So we are going to choose these items in a specific order, going from the smallest one to the bigger ones. So here we have the second condition here, which obviously, if the first one doesn't work, then we move on to the second one. Now, do we choose the next three, or one less than, you know, the other ones? Do we choose the next three or these ones here? I believe it's going to be like this. We are going to choose this one here, right? So we'll check again. Obviously, the conditions here are okay for the first. I mean, this array satisfies the first condition here. For the second condition, right, we'll say 4 minus 1 is equal to 3, so this works. Third condition, right, we'll say 6 minus, now okay, so the third item is k, right? So 6 here, 6 minus minus nubs, right, at j, which is 4, is going to be equal to 2. So this doesn't work. Now, I'm just thinking about a new approach to this question. It's obviously not sure that this method is going to work, but I'm just thinking about something new. So let's move on. If we shift this to choose the next three number, removing the previous one, is this going to work? Obviously not, so this is going to be, but you can see doing it this way, right, doesn't actually work. So it means that we have to pair each number with the remaining ones, right? So which means if we started here, right, we'll do 0 and then 1, 2, 3, 4, 5, right? And then when we move to the next item in the array, we'll choose the, you know, the two next numbers to find if they are possible arithmetic triplets. I'm still not sure how to optimize this, honestly, but I'm sure I'll do my research and come back with a better answer. So that's a bit of revision on the arithmetic triplet. Now, this is a solution here. I'm not 100% sure how this works, but you know, I'm still going to go over and check it out and understand exactly what is going on here. But yeah, so this apparently beats 95% of solutions, which is really good. I'll keep this, I'll bookmark this question, right? I'll just bookmark it. I'll put it in my bookmark bar, or sorry, other bookmarks. So I'll save it and have a look at it later. So let's move on to the next question. Now, find the first palindromic string in the array, which is a very nice question, right? First palindromic string in an array. So how do we find the first palindromic string in the array? Well, for us to do that, we first of all need to understand what a palindrome is, right? A palindrome is simply a string that is written the same way forward, that reads the same way, from right to left and then from left to right. So let's say this string now, P A P, right? PAP is a valid palindrome because if I write PAP or reverse PAP, I'll still have PAP like this. So this is a valid palindrome. Now we have what I usually do when it comes to palindrome. Here is my trick, right? To find out if any string is a valid palindrome. I know there are two types of palindromes, right? Now, what do I mean by that? I know there's a string that can be written like this, PAP, which is a valid palindrome, right? All right. But now, let me write another palindrome and tell you the difference between these two. If I write PAAP, right, this is also a valid palindrome, but there is a subtle difference between these two, right? Now, you can see the first palindrome has one item in the middle, right? In other words, if we flip these letters, we are just going to keep the middle letter at the same position, right? But for this one, right, when we flip it, we'll also switch the middle items as well, right? So going forward, right, I mean reading from back to front, right, when we start writing this, I'll put P, which is this one, A, I'll put this A, and then this second A again, and then this P here, right? It still reads the same as this. Both of these are the same, which makes them a valid palindrome, right? So this is a valid palindrome, a valid palindrome. And I've been using this particular method to solve a lot of palindromic questions, and it has been working just fine, right? So let's say in the case where we are asked to find out if a string is a valid palindrome or not, right? Now, one way to find out if a string is a valid palindrome, without any doubt, there are so many solutions to finding out if a string is a valid palindrome, right? But there's this particular method that I use, right, which is finding out if the item has a single middle or a double middle. Then I can now, so why do I do that? Why do I find out the single middle and double middle? So it is for me to set pointers, right? So let's say I want to validate if this string is a valid palindrome or not. Now, if the string has one item in the middle, then I'll start both my pointers, my left and right pointer at the middle, right, at this position here, and then I'll begin to compare the values where the left and right pointers appear, and then in every iteration I'll increase the left pointer and the right pointer outward until I reach the ends of this string, right? So let's say, for instance, if I were to validate this, if this string was a valid palindrome or not, I'll put both my pointers will start from the middle, right? And then I'll compare, right? I'll compare at this point at the values so I'll call this X. This is going to be my time is almost up, sorry. This is going to be X, right? At the values at X at L, right? Is it equal to X at R, right? X at R. So if this condition is satisfied, or in other words, if this condition is not violated, then I'll move my left pointer towards the left and the right pointer towards the right to increase and conquer, or capture more characters in the string, right? So now at this point we'll compare again, right? We'll compare again X at L. Sorry, let me just use this. We'll compare X at L with X at Y, which is P, and we know, is this equal to this P here, which is true. These two are the same characters. So we then continue increasing until we increase to the point where the left pointer is out of bound, right, and the right pointer is also out of bound. Then we know we are done checking the characters of the string, and then we can go ahead and say whether the string is a valid palindrome or not. Now, for a double a string with two items in the middle, right, or two identical characters in the middle, we start the left and right pointers at this point. So the left pointer is going to be here, and the right pointer is going to be one more than the left pointer, right? So in this case, here's what we need to do again. We increase them outward. So we compare the values at this position. We'll compare these two values. So I'll call this x2. x2 at L is x2 at L equal to s2 at R, right? Are these two values the same? Well, if they are the same, then we begin to expand our pointers outward, right? So we move our left pointer towards the left and the right pointer towards the right, and we'll compare those values at that position, right, where the left and right pointers appear. So if they are the same, then we continue shifting our left pointer until we are out of range, or we are out of the string itself, where there is no more characters to see. Now let me show you why how this works for strings that are not valid palindrome. Let's say we have a string called I'll write a different string. I'll call this s3 and set s3 to maybe LAX, right? Now already this is a palindrome with one character in the middle. So if I set my left and right pointers here, right, and then I begin to compare, right, is item at s3, right, where the left pointer is, is it the same as where the right pointer is, right? We are looking for s3. We are looking at s3 string now. So in this case, yes, we know this is already a valid palindrome. Now, a single character that is part of a string is also a valid palindrome. So a valid palindrome is not just a valid palindrome is not just a single character. I mean, it's not just an entire substring. One character in a string can be a valid palindrome. So, and then we know so far this satisfies the condition for a valid palindrome. So we begin to move our left pointer outwards, right? We'll move the left and right pointer outward. So when we move them outward, we know we'll compare the values at this point. Now in this case here, right, the left pointer, the character at the left pointer is L, right? This L here, and then the character at the right pointer is R. L and X are not the same, right? These are not the same string, so this is not a valid palindrome. X is not a valid palindrome. So that is how we can that's the method I've been using so far to find out about valid palindromes. Now you can do it in a different way, right? Let's say I can use a different method to find out if a string is a valid palindrome. So I'll remove everything from the screen. I'll say let me write a string. I'll use the same string PAP. Now we can use string reversal, right? We can reverse this string, and compare the values. Now that method is very straightforward. If you just reverse this string, I think in Python you can run a reversal function, right, by iterating on the string and resetting the position of each character, which is good. You can reverse it with any built-in method, but there might be cases where you're asked to do more, which is just go out of using so let me show you how you can reverse a string in Python. String reversal, right? So let's say let's define a function. So I'm in my playground, so I'll define this function called reverse string str like this. Okay, now this is going to take a string s. I'll put s here as my parameter. So this is going to be string, and then I'll just return a new string. Oh god, I'll return a new string. I'll return str like this. So now let's see how we can reverse the string. Now since str is a string, we can iterate through we can iterate every character, or we can go through the string by selecting each character in the string. So let's create a for loop, right? I'll first of all create a reversed reversed s, right? Or I'll call this rev s. I don't want to spell everything out. Rev s, and this is going to be an empty string. Now when I iterate through our main string, which is for s in or let me say for I in range length of s, right? Length of s. Now this I here is an index, right? So typically it begins with 0, right? And let me just show you what that is. So print I. I'm not done, so I'll just I'm not done with my function. I just want to show you what I is. So I'll just say reversed string s, right? And then pass it. I'll put the PAP that I was using in my example. When I run this function, you'll see 0, 1 to 2. So you can see 0, 1, and 2, which is simply the value of this I in every iteration. And we have 3 iterations here, which is 3 items in the string. Now, how do we reverse this? Well, first of all, we can build up the string, the reverse form of the string, by simply saying reverse should be equal to the current character, right? The current character and the next one. So I mean the original form of the string, right? So we'll say s at I, right? S at I plus the original version of the reverse string. So this is simply going to take this reverse string, which is an empty string, right? Add the first character to it, and then append the reverse form to it, which is going to be an empty string as well, right? And then this empty string will become p at first. Now the next iteration will add this first character again, and then add the p behind it. So let me use a different string. I'll call this ABC, right? Now when we run this string, we'll see CBA, because A will come first, right? And then we'll append an empty string to it. Then B is next, but we'll put B in front before appending A to it, and so on. So let's see how we can. Let me just return this function here. I'll return reversed of this string. I mean that's nothing. So I needed to close that. So when I run this function now, you can see hold on, there is okay. So I returned it, but let me print it out for you to see. So print this, right? So now you can see CBA, the string has been reversed. So that is how we can reverse a string in Python. And then we can use this reverse form, right, and compare it to our original string to tell if the string is a valid palindrome or not, right? So we can do something like this. I'll say, let me define a function called is valid palindrome, although this has its own downsides in terms of time complexity. Is valid palindrome, I'll say valid palindrome, and this will also take a string, because we are checking for a string, str, and then this should return a boolean, right? A boolean for us, whether it's a palindrome or not. We can return true or false. So then what we will need to do, we'll say the reverse form of the function, reversed string, I'll just call this reverse string, is going to be equal to I'll just put reverse str, my function that reverses a string. I'll put S here, and I'll say return reverse string, right, is equal to S, right? So now if the string is a valid palindrome, we will know. So let me just take this out, and then I'll print his valid palindrome, and then I'll pass it the PAP. Like I said, this is a valid palindrome, and you see we'll get through in our terminal. So let me just run this now. You can see there is true in the terminal. But if we added, let's say, a T here, right? Part is not a valid palindrome. In fact, when we reverse part, we will get tap, right? So it's not the same thing as part. This will give us false, as you can see here, right? So that's how you reverse a string. And yeah, I mean, this is really awesome. This is nice. This is you know this is O of n, right? The function that reverses the string is O of n, because we iterate for every character in the string. And the valid palindrome itself is a constant time comparison, which means the entire function is the entire method for checking the valid palindrome is O of n time complexity. Now I have to end the stream. I'll continue the revision tomorrow because I have something to do quickly. So